Greg, and thank you everybody for choosing this track to sit into. One of the challenges I'm going to have is obviously 20 minutes, right? That's a challenge for me to get anything across in 20 minutes, especially as a technology nerd or geek. I'm pretty excited about what's happening in industry and what the potential can do now for lubrication. So I'm going to walk you through in terms of the need for a truly automatic lubrication system. And really the focus here is the word automated, right? We've been concentrating, there's automatic lubers, there's systems that say to be automatic, but really what is the true definition of automatic or automated, or maybe it's even autonomous if you want to get that far into the pure description of what I'm going to talk about. So who am I? As Greg mentioned, the Director of Global IoT Solutions at UE Systems. UE Systems is been around for 40 plus years in terms of predictive maintenance using ultrasound for bearing inspections, electrical inspections, compressed air leaks, and things like that. I've recently joined UE Systems to help build their IoT product and ecosystem. My background's actually last 3 years was in artificial intelligence and obviously spending a lot of time on data analytics and connecting things together. And that's really what has driven us to this solution. I do serve as an adjunct professor in the Connected Systems Institute at the University of Wisconsin, and I do sit on a number of boards. But more importantly, enough about me. Let's meet Mark. Mark well, this is not actually Mark, but Mark is actually a real customer of ours that's been helping drive the product innovation. And really challenging us to what is an automatic lubrication system. So Mark is a typical reliability engineer responsible to ensure the uptime of the equipment. But like all of us, Mark has a problem. He has hundreds, if not thousands, of preventative maintenance tasks for motors, pumps, fans in terms of being able to lubricate them. A lot of them have inaccessible locations. There's challenging environments where generally speaking, you do not want to be for a long amount of time. But when it comes to specific lubrication issues, now what I'm talking about here is lubrication of bearings, right? We typically see human error as the main cause of lubrication issues, right? Too much grease, too little grease, grease mixing, contaminations of particles and things like that. And I'm sure through all the tracks that you have sitting through, you've gone through a lot of these and how best practices and technology can start to eliminate them, right? So a lot of us can probably relate to Mark. The reality is Mark is losing the war against bearing failure. And the reality is a lot of us are. And there's so many studies out there and most of them agree with each other. There's the odd study that contradicts it. But generally speaking, 1% of our bearings won't meet the expected life, right? 1%. So the other 99%, they are failing prematurely. They're not meeting that design, right? And when we look at that, there's a lot of causes to that. When we think of condition monitoring for bearings, we think soft foot, misalignment, and those do have a big impact on the health of our bearings. But really, and this was a study done by SKF, and as I said, you can look at these studies. There are so many of them, often they get referenced back to the same source, but SKF had a great study out there that up to 80% of premature bearing failures can be traced back to an issue with lubrication, right? And when we look at that, that shouldn't be a surprise for any of us on this conference because we're all here for lubrication. We know the impact that lubrication has on our bearing, right? And when you look at the study, and if anybody wants to, you can obviously just search this study and find snippets of it or find the entire study. You're more than welcome to email me as well, and I'll get it over to you. Is when we look at it specifically, all the failure modes of a bearing in particular, the ones highlighted in blue here are lubrication related. And this is proportional to size to the percentage of failures that they cause. So we have lubrication contamination, excessively long time without renewing the lubricant, unsuitable lubricant, insufficient lubricant quantity. But when we look at that, we can even break that down even further. Insufficient lubricant quantity could be too much or too little, right? So Mark, as the reliability engineer, he's trying to change reliability or lubrication best practices. So he's gone out there and saw what typically is done in industry or a lot of the time, and unfortunately is done by OEMs with equipment coming into our facility saying, every so months, give this a couple shots of grease, right? Some are very bad and just says, you know, grease every 2 months, gives you no idea the amount or anything like that. And if it does, often we use an uncalibrated grease gun and things like that. So what is the challenge Mark would have with time-based lubrication? There is an inherent risk to over lubricate. And I have to fully admit, when I was an asset owner, and this was early on in my career, and I was in charge of motors and pumps, I did that. I greased until it came out the other end, right? So looking at all these problems, right, with these, that we know now that time-based lubrication is not the best strategy. So a lot of industry is moving to ultrasound assisted lubrication. And fundamentally what it is doing is it is letting us know two things with ultrasound guided lubrication. Precisely when lubrication is required and exactly how much lubrication is required. So there are calculations to determine the ideal amount of grease and things like that. But I would challenge anyone to say, is that accurate based on the existing grease that is in there, the condition of that bearing and so forth. So we've seen a large adoption of ultrasound assisted lubrication in industry. And I think that is a great thing. And what that typically is a ultrasonic. We have a specific grease caddy, which mounts onto your grease gun. So you're essentially listening to that bearing, and what you will audibly hear as we heterodyne that signal down is a lot of noise. And when the grease is applied, that noise comes down. And for anyone that doesn't know, what we're doing with ultrasound is we are listening to friction, okay, in forms of a decibel reading. So ultrasound is different than vibration. Vibration has a lot to do with movement. In this case, ultrasound at about 30 kilohertz or above, we're listening to that early onset of friction. And of course, what is the purpose of lubrication? To reduce the friction, right? So we're listening to that. Ultrasound is the first technology to pick up those early warning signs of a lack of lubrication. What we want to do is ideally have that thin film, obviously on those balls in that bearing, but not over grease it. So what our grease caddy does and what technology or ultrasound technology in the industry has been able to prove and implement is that we monitor those dBs. And as we're monitoring the decibel or the friction in that bearing, as we add grease, that decibel level will start to decrease. So it's very simple. We can trend that decibels, or we can actually listen to it as well and audibly hear it, right? So if we started to lubricate that bearing and it already had sufficient grease, let's just think about that for a minute. What we're doing is we're adding more friction. Yes, we're adding grease, which is the intent to reduce friction, but by adding more into a limited space, we're actually causing more friction. So we'll see that decibel level start to increase, indicating that we've over-greased it. Now, if we start to add grease and there's no change, there can be a few things wrong. First of all, you could have compromised the seal, which is very common with over-greasing, and grease is starting to get somewhere other than in that bearing. And the bearing is in a failure mode that is beyond lack of lubrication. Often we can see the decibel level start to dip very for a short duration and cover up those early bearing defects. But of course, quickly that decibel level comes back up and will start increasing. So we came out with this idea of putting these ultrasound sensors, instead of us going to these units to lubricate, let's put these permanent mount sensors on there. So on any device, anywhere in the world, you can start to measure the decibel or the friction level of your bearings. And what the intent was, and what our users are using, this product's been out there now for a number of months, is they're using a cell phone and watching that decibel change in real time as they're applying lubrication. And what they're looking for is this. This happens to be the way we look at lubrication. One of the ways we look at lubrications in terms of this on-track system. And what we're looking at here, it's very simple. It's what I call very prescriptive human-centered design. Arrow is in green, and I can do that while I'm looking on an app on my cell phone, right? You can imagine I'm with a grease gun in one hand and a cell phone in the other, and I'm greasing this. If that arrow was in the green zone, that's a healthy working bearing. If it's in the blue zone, it needs lubrication. There's no if, ands, or but. That thin film, the friction level indicates that we need lubrication. We lubricate that bearing, and what we do is we, in real time, as we're applying lubrication or grease to that bearing, that arrow drops back down to the baseline. So back into the grease, in the green zone. When we've done that, that means we have sufficiently lubricated that bearing. It really is that simple, right? And now with technology and with IoT, we can get this information to anybody, anywhere, on any device. So this is what it looks like. Now I'm going to ask you to ignore some safety concerns you might have with this, because obviously you would want that fan moving while you're greasing that bearing. But this gives you an idea. Here is one of the person that works for Mark. He's holding the grease gun and he's watching that decibel, that friction change in real time. There's no wires connected to him. He's using a cell phone. We've had customers use a tablet. In fact, we have one customer, if anyone's ever seen this device before, it's called the RealWear headset. And it's actually a optical here, and you can actually see the real time and keep both hands free while you're lubricating. Isn't technology great? But now the challenge goes back to why you attended this specific talk. We're still looking at manual. Yes, we've automated the point of getting that friction, that decibel reading to you at any point in any time, but it still requires someone to go out there with the grease gun. So when we looked at this, I said 80% of premature bearing failures can be traced back to improper lubrication, right? And we break down improper lubrication. Let's take a look at inadequate lubrication. There's too little, too much. Contamination. Contaminated lubricant is a big problem. We all know what the impact of having stuff in our lube. Unsuitable lubricant, a huge problem. How often do you see, and a lot of people say, put specific grease nipples, different colors and things like that, so you can't use the wrong lubricant. And that is great practice. But what if there's a way that we can eliminate the majority, inadequate seals and things like that? There's not much I can do with technology, because you need to design and spec that bearing properly, right? But let's assume you've done that. What are the other things we can start to do? How in this online system of IoT can we start to control unsuitable lubricant, right? Is there a valve I will only open up if I know it's the right lubricant, right? Those are the type of challenges that we're starting to face. So in comes the automatic lubers, and wow, have these things taken off in the last few years. Even so, when I've talked to a lot of the manufacturer of these, they start to talk about the increase over the since COVID. COVID has happened, eliminating people to go out there and lube. So they go out there and they install these one-time systems, right? What's great about these is they're typically based on time. So when using these, we're going back to that first conundrum that Mark had, was time-based lubrication, which we know is not ideal for the majority of applications. Now, there are applications where time-based will meet their requirements, right? And I would challenge you, even with time-based, using ultrasound, you will be able to further fine-tune that time interval. What's great about these automatic lubers is they inject or deliver a very precise amount of lubrication into that bearing, right? So it's not like a grease gun that's subjective to how much is in a certain squeeze of that grease gun. It's very specific of how much is going in, and you can control that. Where I got most excited with these automatic lubers, and you can have multi-point designs that requires tubing and you're pushing them through a distribution block and things like that, but the cost point and solutions now for a single point luber is ideal where we need to be in market. There are some challenges with these lubers. Some of them are battery operated. There's plastics designs that can cause concerns, although I have tested them. I'm not concerned about them. They do require a checkup. And the idea is, what happens if that leg line or that impulse tubing gets plugged and you think it's lubing, but grease might be coming out fittings or it's not getting anywhere, right? Malfunction is a concern because you literally set it, forget it. A lot of them have dip switches and things like that. So there could be a concern, is it working or is it not? The last thing you want is, I failed because of lack of lubrication, but I had an automatic luber on it. So here came the challenge. So here we have an on-track system that's measuring that friction in real time, anywhere, any device. I can pull up this information and look at the friction on that bearing. I know exactly when and how much to lubricate it. On the other hand, I have this automatic luber that's sitting over here that's based on time base. What if we combined the precision of ultrasound with the convenience and accuracy of an automatic luber? To me, this is game changing. This is where we need to get with technology. So what we've done is we've integrated automatic lubers, both wired and Bluetooth, to make it completely wireless free, right? So you can start to imagine, and what you're seeing, and you can actually see, I'm not sure if you can see my mouse here, on the top left, you'll see an actual image of a live decibel change. And what you can see here is it drop down on the left-hand side below that yellow line. This is actually when lubrication was applied. We can see the resulting decrease in decibel and friction as it's being applied. So what we have tested out there in beta testing is that we can accurately control an automatic luber from any device anywhere in the world, right? So no longer do we have to go up there and actually lubricate. We hit a button on our cell phone, on our PC, and it injects a precise amount of lubrication. Now, it doesn't mean you don't have to sit there and lubricate, wait a minute, right? There's built-in safeguards where you can't over lubricate it, and you do have to wait till that lubrication gets entirely around the bearing itself. So there's safeguards in place. You have to lubricate. In most cases, it's around half a cc, but it can be customized in terms of how much lube gets entered in there. And then you'd wait to see that decibel change, and then you would lubricate again if required, and keep doing that and over again. Now, the one issue that I have with these systems, with these automatic lubers, is what if something was to clog, right? What other information? What if I had no lubricant? My canister or cartridge in that automatic luber was empty, and I'm hitting a button and I'm lubing it, but it's not going down. Something's going wrong. Must be a bad bearing, right? I need to get some feedback, right? In this world of IoT, it's all about not just data, but information. So what we're able to do is capture the real-time information while we're lubricating this device. So we can lubricate from anywhere, anytime, but also look at the remaining grease level. So how much do I have left in terms of percentage, right? But a percentage is relative, right? And that's really where you think of a gas gauge, for example, in our cars, right? We used to do quarter tank, half tank, 3/4, and full, right? And most of us would extrapolate how far we can drive, but now we have, distance to empty. So these warning alerts, excessive back pressure. So if we have a clogged line or that bearing is not accepting that grease, boom, we know that we need to go out there and get to that bearing. And by all means, I do not believe technology is going to replace specialists like many of you are in lubrication. This is going to aid in or benefit from your experience. Obviously, low battery for completely wireless, end of lubrication cycle. We bookmark that so we know, hey, last time when I lubricated this, I had to use X amount of grease. It gives me an idea how much I need to do next time. Obviously, the number of days since we lubricated and the replacement cartridge date. So we're starting to look at that miles to empty. Well, at this rate I'm going to run out of grease. In case of a motor, it might be a long time. In case of something I need to lubricate more frequently, it might be a month. I better get one on order so that I am ready to go when that cartridge gets low, right? So now we're starting to look at bringing more information, not just friction, but more information. And these are truly intelligent devices now that we're talking to. So here comes the point where I talked about automatic. So when we were in, I'll go back here, when we were in this mode, we're looking at manual ultrasound assisted lubrication. Manual in the sense that we are pumping grease into a bearing. What about, and then, sorry, we go to something, a system like this, where we're hitting a lubricate button. It's remote ultrasound lubrication, but it's still manual. We're still taking human intervention. And my experience in artificial intelligence is a lot of the times we are not ready to fully trust a system that we have not programmed or know to do things. And this system is typically if you had to put into a bucket, it would be called a condition monitoring system, right? But it's more than that because it's an active system, right? Because we can inject grease into a bearing. So we're actually doing some level of control. So EFRI did a study, which is a really good study in terms of developing the algorithm where the logic is not artificial intelligence by any means, but we do have a roadmap for that to learn, to be able to anticipate when a bearing is going to require lubrication. But there is an automatic mode setting that's going to allow us to put it in auto, that when it sees that friction change over a certain amount, which is typically 8 decibels, it is going to inject a certain amount of lubricant to bring it back to baseline. If it didn't hit baseline, it's going to wait a few minutes, let that grease settle, and do it again, right? If we lubricate it, we get the excessive alarm and things like that. It's going to go into a certain mode, right? So it's really designed to be left in auto, and it's going to take care of all that lubrication, supervised by someone though, right? All these insights of when it lubed, how much it lubed is available to you. Now, this is an example of what we did when it was sent in automatic lubrication. You can see the resulting change, a very drastic change in decibel readings as the automatic luber was dispensing it. We're doing a number of tests to figure out what the best algorithm is. And I think a lot of people from industry, and if you have an idea and want to help with this, then by all means provide some feedback. Because I truly think this is going to be the way to go, where you set this in auto, and of course, if it doesn't work, it's going to flag you, but you no longer have to sit there and watch to make sure you're lubricating these properly. Now, there are lubricators out there, automatic lubrications, that are using vibration sensors and things like that. But what they're doing is they're making sure the equipment is running before it applies lubricant, right? Before it injects that grease, which obviously you want that to happen, but it's not looking at it as a truly smart system of measuring friction. So when we look at this, what I'm calling this is obviously it's automatic bearing lubrication, but it's really bearing lubrication certainty. And over there on the left-hand side, that is a picture of Mark celebrating our first win as it automatically put the grease in at the right amount of time, at the right amount, didn't over grease and things like that. So really what Mark has now from these specific bearings is bearing lubrication certainty. And this is on the right-hand side, Mark sitting down in the airport, actually watching his trend, and should he want to and have the right security access, could hit that button and inject a known amount of lubricant and watch the friction in real time from anywhere, any device. Now, I think that is game-changing technology that's really going to affect how we look at true and the need for automatic bearing lubrication. So that was it for the presentation. I'm going to guess we have some questions coming in.